online. My name is Norwin Phillips, and I'll be your instructor today. And I'll be presenting you with a lab that we're going to work through on network address translation. Let me just share my screen right now so that y'all can see it. All right, so we'll be looking at this topology, which is already pre-configured, but we haven't actually configured the um, the network address translation portion of this lab, and I'm going to walk you through configuring network address translation. So let me just label the lab here. It's NAT, network address. Oh, my spelling is not very good. Yeah, address translation. Right. So pretty much, network address NAT allows us to be able to leverage one public IP address to access all resources on the internet. I'm using this web server down here to simulate the internet. And I'm using this router, which is iNet router 02, to be my edge router. A matter of fact, what I'll do, I'll rename it and just say edge router, EDGE edge router 01. So this is the router that sit on the edge of my network. It has connection to my internal network, which is the LAN on this side, and it has connection to also another LAN and the internet. I am going to get this tool here that I like to use to draw so that I could, you know what, I'm going to forego that for right now. I was going to get this tool to draw so that I could do some animation, but I just started using this program and I'm not sure how that will work. So let's forego that for right now. So as you can see here, my PCs are pre-configured using DHCP and they have their IP address and full reachability. I could test that I could ping. Let's go to PC3 over here and look at the desktop. And I could test that I could ping from PC1 from PC2 to PC3. Let's take a look at that. So if I were to go here and go to the command prompt, I could actually ping, right? I could ping 172.16.1.21. And hopefully that comes up. And if it's not working, then we could always fix it. Right, there you go. It's pinging fine, no problem. All right, no problem. We're not having any issues there. And notice, if I were to go from PC1, which you can see here, if I were to go from PC1 all the way to the internet server, let's see if I can ping it. So I go to my command prompt and I say, hey, PC1, I want to communicate to 209.165.23.100, and it is not working, just like we expect. Now, let's take a look at why this is, this is happening. So I am going to go to, I'm going to go to my internet router here. And if I look at my internet router and say show IP route, I'll realize that, hey, but I don't have any, access to go back to 198, 192, 168, 1.0, because that's where PC2 is coming from. Now, we notice that it's not pinging, but even let's take a further look at it, and we're going to use, do a debug, right? So we could do debug IP packets. And if we debug IP packets, we can ping again. Now, let's look at PC1. Sorry, PC2, pardon me. If I do IP config, notice I can see the IP addresses that are configured here. I'm configured with 192, 168, 123. And this is my subnet mask. This is my default gateway, right? So I just configured that there. Once I do that, if I were to come and do a ping, right? If I were to do a ping here, ping, ooh, and what's the server IP? 209.165. at 23.100. Look at what happens. On my internet router, I could see that my pings are getting there. Let me stop that right there. I could see that my pings are getting there, and look at where it's telling me that the pings are coming from. The source address of the ping is from 192.168 1.23, which is the IP address that I have configured here on my PC. And it's trying to get to 201.165.23.100. So you see the traffic is getting there. But when we looked at the router previously, we saw that there are no routes going back there. And that should be so, because we already know that private IP addresses are not routable on the internet. So we call these, RFC 19 addresses. Let's see. RFC 19 RFC 1918 addresses are the 10.0.0./8, and it's 172.16.0.0/12, and it's 192.168.0.0/16, right? So we know that these are not routable on the internet. So rightly so, the router doesn't know how to get back to it. So normally what happens, think of you being in your home with your wife, your kids, your cousin, whomever is living there. You normally have one public IP address, and I'll just label this right here, where my public IP address that I got from my internet service provider is 201. Pardon me, it is not that. It is 66.175.12.1, right? That's what I got from my provider. And that's what on this interface here. We could actually go on that edge router and take a look. How do we take a look at this? We go into privilege exec mode and we could do show IP interface brief, and we could just say exclude unassign, and we will see that that's the public IP address that's assigned there. Now, this is the IP address that's assigned to this side of the LAN, and this is the private IP address that's assigned to this side of the LAN, right? This is my public IP address. Now, if you notice, let me go back to my desktop and I'll go back to the command line. I was trying to ping 209.165.23.10. If I were to go on my router and try to ping 209.165.23.100, right, I am able to ping, no issue whatsoever, right? And I was pinging the wrong IP address. Yeah, I pinged the right IP address. Okay, here. But if you notice, I am able to ping from the router, no issue whatsoever, right? And that's perfectly fine, because if I were to go to router 2, which is my internet router, and take a look, I see in this case when I'm trying to ping, right? Let's do that again. And what I'm going to do is I'm going to check this for this to stay on top so that we could see it and relate to it. And I'm going to go back to the edge router 1. So if I go back to the edge router 1 and ping, if y'all notice right here, right, this is the ping coming through. It says, hey, Norwin, you're pinging from 66.75.12.1, and you're pinging to 209.165.23.100. I'm able to get there, and the traffic is going back. If you look previously when I ping and it came from the workstation, it is saying that, hey, I got your ping, but your ping was coming in from a source with an IP address of 192.168.1.23. And guess what happens? Unroutable. I don't know how to get back there, right? So we're going to fix that. That's where NAT comes in. So what you have to do now, you have to enable network address translation. Network address translation must be enabled on this router, right? And we're going to walk through the the process of doing that, right? So let's walk through this process right here. So on your edge router, let me just close that PC for a little bit. What we want to do, we're on this router right now, on the edge router. We're going to go into global config, right? And what we're saying is we're going to build an access list. So let's say, access list, access list, let's give it 10. access list 10, and we're going to permit this network, which is 192.168.1.0, 192.168.1.0, and we're going to put the wildcard mask 0.0.0.0.254 and 255. And once we do that, we hit enter, right? And so now we have created our access list. We can go through and look at the running config, and we will see our access list here. The other thing that we need to do is to create the NAT, right, which is IP NAT, right? And we say inside source list, and the source list we're going to refer to 10, right? So pretty much we're saying, hey, network address translation technology, I want you to refer to this list, right, to know what network you need to translate for. So here I'm saying IPNet inside source list is 10, right? And I'm saying the interface that you're going to translate on is gigabit 001, which is the outside interface, gigabit 0/0/1. And I want you to do what's called a NAT overload. A NAT overload is pretty much you're going to translate every system that is coming from the inside network is going to be translated to the IP address that's configured on this interface, right? So now, once we do that, we could go back up here and we could show run, and we could say, hey, here is our command, right? Here's our command right here. Now, I'm going to save my config. Now, if we do that and we went back to PC2, what's going to happen? It's still not going to work, but I just want to walk you guys through the process, right? So if we were to go here and say ping 209.165.23.100, it's still not working. And we could look right here, at our we could look at here at our router. It says, hey, I see the traffic coming in from 23, man, and you're trying to get to 209.165.23.100, but it's unroutable. I don't know how to route for that, right? So let's kind of leave this here. What I'm going to do, let me do a continuous ping. I'm going to say -T, hit enter, and just let it sit there and continue, right? So again, the debug is also, I'm going to stop the debug for right now. To stop the debug, I'll do undebug all and hit enter. Debug is turned off. Now we're going to go back to the edge router. And once we go back to the edge router over here, we're going to start looking at a few things. So what do we need to do? We need to now identify which of these interfaces are inside interface and outside interfaces. So we could say inside interface means the interfaces that are on your private LAN. So serial 010 is your inside interface because it's on your private LAN. Gigabit 000 is also an inside interface because it's on your private LAN. Gigabit 001 is your outside interface because it's on the public internet. So let's go into the interface config mode and turn on these configs. So I could go into interface gigabit 0/0/1, and I would type this command IPNAT right outside. I'm identifying this as my outside interface, and I'm going to go into internet interface serial 0/2/0, and I think I screwed up. So it's interface 01/0, and I'm going to say IP NAT inside, right? And now it starts translating, right? Because it knows that now this is my outside interface, this is my inside interface, and it is using the access list that I just created. So if I were to do run, it's using this access list and it's saying, hey, any traffic that is coming from this network going to the internet, what you need to do is convert it to the IP address that's configured on this interface. That is gigabit 001, and gigabit 001 was just identified as the outside interface. Notice on gigabit 00 over here, I did not identify it yet, but it will be identified as a inside interface, right? And and also serial 010 is identified as an inside interface. So you notice the traffic is we're getting a response now on ping. And if we were to go to the internet router, let's look at it here. And if I were to turn debug on, so if I say debug IP packet, look at what happens, right? Look at what it's seeing it as. It is saying, hey, I'm seeing your traffic. The source of the traffic is coming from what? 66 175.12.1, which is this interface, because that's where the translation is happening at, right? And it's going to 209.165.23.100. No problem, it's getting there and come back. Now we could also look at the let me kill the ping over here. I could also now look at my edge router, and if I were to look at my edge router here, guys, I should be able to show IP network address translation, and I should see all the translation that's happening. So pretty much it's saying, hey, anything that's coming from 192.168.123, translate it to this, right, to send it out to the internet. So this internet now will know how to get back to the 66 175 12.0 network. You see, that's what's going on here. And if you so now just to bring a little bit more clarity to it, we were only looking at PC2. So let's look at PC1. If we go to PC1 and we take a look at it, we see PC1 is configured with 192.168.1.22, and we can now go to the command prompt and we could say, hey, I want to ping 209.165.23.100. Notice it's pinging also. If we go back to our edge router and we were to do a translation, we'll see that it's translating for 22 also. And let me go back up here and ping again. So in addition, if I go back and show the translation again, you see that it is translating for both, right? PC with IP address 22 and the PC with IP address 23. So regardless of what computer I put on this 192.168.1.0 network, it will translate for it. Now, let's walk over to this side of my LAN. Now, notice I did not turn on gigabit 001 as the inside interface yet. So let's do that. Interface gigabit 0/0/0. Pardon me. If I were to do show run, notice it's not turned on yet, right? So I'm going to identify it as an inside interface, and that is IP NAT inside, and hit enter. And if I go back and show run, you will see that it is now an inside interface. So now you would think that once it's identified as an inside interface, if I were to try to ping from one of these PCs over here, PC3 here, it should work. So let's try and see. It will not work. And I'll tell you why. 209.165.23.100. It is not working. And we can also go to the internet router and see why it's not working. So right now, let's go to the internet router and see why it's not working. Look at right here. Let's go back to PC3 and let's pull up the internet router. Well, we can look at PC3 and see that PC3 is configured with 172.16.121. And it's saying, hey man, I am getting a ping from a source which 172.16.121 going to the destination network of 209.165.23. However, when the destination network, which is 209.165.23.100, is trying to respond to 172.16.1.21, it can't get there. It says unroutable. Let's look at the routing table. Show IP route. It doesn't know how to get back to a 172 network. But the bigger question is, why is 172 showing up out here on the internet when we know that these IPs are not routable on the internet? Huh, where did we go wrong? All right. It's not that we did anything wrong, it's just that we haven't done it yet, right? So let's show here. Let's look at the configs again. We notice that we've configured network address translation on gigabit 001 interface as the outside interface, right? So we're saying, and we notice that we're calling, source list 10. So we're calling the access list, but in the access list, we have only specified that translation should be done for 192.168.1.0 network. So that therein lies your problem, right? So if we were to go back over here and start pinging, I'm going to do a continuous ping just so y'all see it. Look what's going to happen. As soon as I go inside here and I say access list 10, permit 172.16.0.0 with a wildcard mask of 0.0.0.255 and hit enter, now my ping should start working. Oh, I screwed up. It's not, it's 172.1. 172.16.1, not 172.0.0. So let me just add that in there. Access list 10, permit 172.16.1.0, 0.0.0.255, my wildcard mask, right? And we should be good. Let me just put a space there. And there you go. And look at that. We're pinging right away, right? So that's what's going on now. Now, we no longer see on the internet router, if you had access to an internet router. Right now we don't. So of course we have used packet tracer to create this topology, which allows us end-to-end visibility, right? So you notice now, guys, that we're no longer seeing the source of the ping coming from the 172 network. I'm just trying to scroll back up to where it was, it was failing. So up to this point, the source of the ping was coming from 172.16.1.21. But once we have corrected that, we notice now that the source of the ping no longer came from 172.16.21, but rather the source of the ping will now come from the IP address that is configured on the edge router, right? So the source of the ping should be coming from now 66.175.12.1, right? And that is how network address translation works in a nutshell, right? So I hope this has been informative for you, and I'd like to thank you for viewing. I want to welcome you to visit us at Network Academy Online. You will see the URL just right there at the bottom of your scroll bar, where we have plenty of labs, that will provide you with some insight and overview. And if there are any labs that you'd like to see, I encourage you just to drop me a note, and I will be more than happy to configure those for you to do some demonstration. Again, please please subscribe, tell your friends, and happy networking. See y'all soon.